This is Physical Chemistry, Chapter 10. We're doing Section 11 now. What if we have a non-ideal gas mixture? Well, then we're going to talk about fugacity, F sub I, is going to be the effective pressure in a mixture of gases. So we have the fugacity of substance I divided by the standard state, P naught, and that's going to be the activity of the substance I. So Fi has unit of pressure. Fi is intensive. And remember, of course, the standard pressure is 1 bar. Now, for an ideal gas mixture, we have the chemical potential of the substance I, ideal, is equal to the chemical potential of the substance I in the standard state, plus the gas constant R times the temperature times the natural log of the partial pressure of the substance I divided by P naught. Now, for a non-ideal gas mixture, then, we'll have the chemical potential of the substance I. That's going to be equal to the chemical potential of the substance I in the standard state plus RT times the natural log of the fugacity of the substance I divided by P naught. So the fugacity plays the same role as partial pressure that we had in an ideal mixture. Now, as the pressure approaches zero in non-ideal gas, then the mixture, the fugacity of the substance I, approaches the partial pressure of the substance I. So fugacity approaches partial pressure as pressure decreases. Now we're going to use symbol phi to be the fugacity coefficient. So we have phi I is defined as F sub I divided by Pi. So the fugacity of the substance I is equal to phi I times Pi. And remember, the partial pressure of the substance I is equal to the mole fraction of the I times the total pressure. That's always valid. Now the fugacity of the substance I there is equal to the phi I times the mole fraction of the pressure. So X, remember, is the mole fraction of the substance I, and then P is the total pressure. So here we have a graph comparing the chemical potential of the substance I versus increasing pressure. So what will happen as pressure increases, here's an ideal gas mixture. When you're at low pressure, the attractions dominate. So the fugacity is less than the partial pressure. But as you get too high and the molecules get close together, then the repulsions dominate, and then you have the fugacity is greater than pressure. So this here is your non-ideal gas mixture. Okay, that is all for Chapter 10.